What if a huge chunk of what we think we know about the universe is just plain wrong? Welcome to The Explainer. Today, we're diving into a really fascinating theory that flips our standard model of cosmology on its head and might just solve two of its biggest mysteries at once. So, let's start with the current picture. Our best map of the cosmos tells us something pretty wild. Everything we see, all the stars, the galaxies, you, me, that's just 4% of the universe. The other 96%? It's a total mystery, split between something called dark matter and something called dark energy. You know, the Big Bang Theory is a fantastic story. It's our best explanation for how everything began, but it's kind of like a movie with huge, important scenes just missing. It leaves us with these two giant plot holes, dark matter and dark energy, that we've been trying to figure out for decades.
All right, so let's jump into a new perspective that tries to fill in those missing scenes. It's called the big inflation theory, and it all hinges on one simple but incredibly powerful new idea right at the dawn of time.
We're all familiar with the four fundamental forces of nature, right? Well, this theory suggests there weren't four forces at the beginning, there were five, and this fifth force is the real game changer. It's space itself, what we now call dark energy. So picture this, the first fraction of a second of the universe's existence. The very first thing to happen is that this fifth force, space, breaks free and just goes. It causes the universe to inflate at an absolutely incredible speed. Then, an instant later, boom, matter condenses from energy. And with matter comes gravity. And what does gravity do? It slams on the cosmic brakes hard.
And that single sequence of events, the gas pedal of space followed by the brakes of gravity, sets the stage for the entire history of the cosmos. It becomes this constant, epic struggle, a cosmic tug-of-war between two relentless forces. This car analogy explains it perfectly. Think of the universe as a car, where the gas pedal, the push of space, is floored from the very start. But almost immediately the brakes, that's gravity, are jammed on and the car slows to a crawl. For billions of years, the brakes are winning. But as the universe expands and galaxies spread out, gravity's grip starts to fade. And what happens when the brakes fade? Well, that gas pedal, which has been on this whole time, starts to win again, and the car begins to accelerate.
And this is the key insight right here. The accelerating expansion we see today isn't some new, mysterious force that just kicked in a few billion years ago. No, this theory says it's just space getting back to its old self. It's the universe resuming its natural speed now that gravity's influence is getting weaker over those vast distances. In other words, inflation never really stopped.
Okay, so this one idea does a pretty good job of explaining dark energy. But what about the other big mystery? Let's get into how this single force could have two faces and, in doing so, maybe solve the dark matter problem for good.
The whole reason we think dark matter exists is because galaxies are spinning way too fast. They should fly apart, but some kind of invisible mass seems to be holding them together. But this theory asks a radical question. What if it's not matter at all? What if the thing holding galaxies together is the exact same force that's pushing the universe apart? If you look at the standard model again, you have two totally separate, unknown things that just happen to make up 96% of the cosmos. Doesn't that feel a little convenient? A bit of a cosmic coincidence?
Well, with this new idea, the picture becomes so much cleaner. It's really elegant. The two mysteries merge into one. There isn't a pushing force and a pulling substance. There's just one thing, dark energy, the push of space, that accounts for that entire 96%.
So how in the world does a pushing force hold a galaxy together? It sounds counterintuitive, I know, but think of a galaxy like a bubble. In the vast, empty voids between galaxies, space is expanding. It's pushing outwards. And that push exerts an inward pressure on the skin of our galactic bubble, squeezing it, holding it together. This external push mimics the effect of extra gravity pulling from the inside perfectly.
So this idea doesn't just neatly tie up two loose ends. It fundamentally redraws our map of the universe. It changes the very geometry of space around stars and galaxies.
In the standard model, a galaxy's gravity is like a simple dip in a mattress. If that were true, stars at the edge of the galaxy should be moving much slower than the ones near the center. But they're not. The big inflation theory explains this by saying that the outward push of space creates a raised rim around that dip, a kind of gravity mound. And it's that external pressure that keeps the outer stars whipping around at such high speeds.
So, it all comes down to this cosmic battle between two perfect nemeses. Gravity is the heavyweight champ up close, around planets and stars, but its power fades with distance. Space, on the other hand, is weak locally, but its push is relentless and adds up over huge distances. Across the vast empty voids, space always wins.
And this isn't just some abstract theory. There are actually real-world puzzles this idea might solve, like the famous Pioneer anomaly. For years, scientists were baffled because NASA's Pioneer spacecraft slowed down just a tiny bit more than expected as they left our solar system. But what if they were just coasting slightly uphill? This theory suggests they were fighting against a tiny gravity mound created by the faint, constant push of space itself. And all of this leads to one final, really profound question. When we say the universe is expanding, what's actually happening to the fabric of space? The amazing thing is, we might actually be able to find the answer. By studying how the light from distant galaxies gets distorted on its long journey to us, we could finally learn the truth. Is the fabric of our universe stretching thin like a rubber sheet? Or is brand new space being woven into existence in the voids every single moment? Now that is a thought to chew on.